Hello, my name is Bahlous-Boldi, and this is my CS206 Evolutionary Robotics final project. The purpose of this experiment is to compare two different approaches to evolving a robot that can destroy a tower, either scaffolded learning or non-scaffolding learning. The things that we're evolving is a neural network controller of the robot, and the evolutionary algorithm I'll be using is a simple genetic algorithm. Here's an example of some completely random behavior. As we can see, the robot controller has completely random weights. The fitness function I'll be using is distance from the origin in the y direction if the tower did not fall over, or 20 points if the tower did fall over. And the way we're going to compare scaffolding and non-scaffolding is that scaffolding, the tower will start close by and slowly move away, whereas non-scaffolding, the tower will start far away and stay there over the course of evolution. This is the result with no pre-training at all. We can see this because the tower stays at a constant distance, which is 4 units away from the origin, over the entire course of evolution. It took about 150 generations for the robot to actually destroy the tower, and we can see that each robot was evaluated for 1,500 time steps, and there's 100 robots in each generation. And we can see that the robot eventually does go and destroy the tower, just as the goal was tasked. Here are the results with pre-training. We can see that 300 of the first generations were used pre-training, and we can see that because the tower slowly gets farther and farther away, and then at the 300 generation mark, the tower jumps up to being 4 units away. And now we can see that the gait that was produced is a lot more unconventional, where the robot almost flips over and starts walking on its hands. But towards the end, at nearly the 600 generation mark, one robot does actually figure out how to destroy the tower, and we can see that because the blue line is above the orange line at that point in time. A possible reason for this is due to overfitting to the generations where the robot is pre-training. Because the tower starts really close by, there's a complete different task that we're actually evaluating for. The robot could just do a flip over and hit and knock over the tower, and then that means that all the robots in the entire population have those genes, which means that then evolution has to rediscover a way to move after the flip over gate has been discovered. To ensure that my results were accurate, I repeated the experiment again with 1,000 generations, this time only 5 creatures in each generation. We can see that it takes about 600 or nearly 700 generations to actually destroy the tower, but it does eventually do that. And then once one creature destroys the tower, all of them are able to, and the average fitness shoots way up towards the end. And we can see this is the gate that was discovered with no pre-training at all. And eventually the tower does indeed go and get destroyed, as you can see. This is the experiment with 500 generations of pre-trained previously. We can see that the flip over gate also happened here too. So the robot flips over and then it learns to flip over again. And that explains why it gets a lot of fitness early on. And then once the tower gets too far away for it, it can't do anything and it gets stuck at a local optima right here. As you can see, it gets stuck, can't do anything from there and does not destroy the tower.